All right, so hopefully most of this stuff you're at least familiar with. I know it's been a while since we've talked about it, so you might have been a little bit befuddled. But we'll just wander on through it, all right? So first one, it says, which statement is an example of a defined term? So yes, this is way back to September when I did not even know who you guys were. And you all would come into class every day really quiet because you were a little bit scared because he's that tall guy with the beard. And you'd sit here real quietly. We had a seating chart and I didn't know who you were, you didn't know who I was. And now you come in and you don't respect me and you talk all the time and I hate my life. But 9 months ago we talked about undefined terms, defined terms, postulates, and theorems, the language of geometry from the very beginning of the class. So, which statement is an example of defined terms? A, through any 2 points, there's exactly one line. What do you think?
No.
False. What is that called? Does anybody know?
Isn't that
A conjecture. Yes, that's absolutely correct. Which the state vocabulary I think they use, they call that a postulate. But that is something that we just sort of know is true, okay? And we don't have to prove it, it just is obvious, okay? B, all right triangles are congruent. Is that a defined term?
No.
No, what is that?
It's not true.
It's not true, but that would be what we would call a theorem or a conjecture. That is something that you would need to prove with a logical argument, a set of logical statements to be true. Okay? How about C? If 2 angles form a linear pair, then they are supplementary.
No.
No, that's a little if-then statement there. And so that leaves us D. A polygon is a closed plane figure formed by 3 or more line segments. So yes, that is a definition. That is a defined term. It's a definition of a polygon. Okay? All right, number 2, all of the statement, if 2 points lie in a plane, then the lines containing those points lie in the plane cannot be proven. It is agreed to be true. Which type of statement is this an example of? Well, I just said it. That's a postulate or an axiom. That's something that is so obvious that we don't have to prove it or anything like that. Okay? All right, which is different from a theorem. Which statement is a theorem? A theorem is something that is not quite so clear to everybody that we need to maybe explain our reasoning a little bit. So an endpoint is a point at one end of a segment or the starting point of an array. Is that a theorem? No, what is that? That is a definition. That's the definition of an endpoint. B, if 2 angles are complementary to the same angle, then the 2 angles are congruent. Yes, that is a theorem. That's something that seems like it probably is true, but we would need to use some logical reasoning to prove it. So that answer is B. Okay?
Wait, so number 2 is C.
Huh?
What's number 2 C?
Number 2 was C. Yep. Okay, 4. Given AF is congruent to FC and angle ABE is congruent to angle EBC, which segment is a median of triangle ABC? So we better draw ourselves a picture here because yes, it doesn't make any sense at all when you just try and look at it and read it like that. Tried drawing a picture and still didn't make sense? Okay, always a bad sign. All right, so here's our triangle and it says ABC. Okay, then it says AF is congruent to FC. So where is your F?
I put it in the middle of AC.
Okay, so let's put it in the middle of AC. Because then this is congruent to that, right? Okay, does it have to be in the middle of AC? Couldn't it be over here somewhere too? Okay, so let's just keep that in mind as we go. Then it says ABE. Where's ABE? There is no E. That's not cool. ABE, I'm thinking that they might want to have that be an E right there. Let's change that to E. And then it's going to make sense. No, change that to an E.
I know, but that one's F.
It's nowhere. It's an E now.
But
There is no F. So say, just change it to given segment AE is congruent to EC. Okay? And so here's our point EC. So now we'll say ABE is congruent to, so we got this congruent to that. Okay? Which segment is the median of ABC? What? AB? AE? No, I don't like AE. BE. Yeah, BE.
okay, well, I put BF, so I guess.
Yeah, so that's probably what they're trying to, yeah, that'll work. Yeah. I want to say that's a typo, yeah.
BF will work.
Yeah, depending, right, because they were screwing up with the E's and the F's there.
Oh, I see.
Yeah, the triangle or.
Right? Okay. Good, good, good. I understand why you struggled with this a little bit then while I was gone. All right. Okay, so now we have, well, maybe it's not a typo. Maybe we'll figure this out.
Do you have the answers somewhere?
Yeah, I do. We don't need no stinking answers. So let's see, this is triangle ABC. And now we have segment AF is congruent to FC. Okay? So is that the same thing we started with on the other one?
Yeah.
Not the exact same problem as the other one?
That one has the altitude. It says right there.
But it's the exact same starting, isn't it?
Yeah.
Yeah, that's the same thing to begin with. And altitude of ABC is, okay, so let's give up on that and try number 6. Okay, so PX, PY, and PZ are perpendicular bisectors. So, tell me something I know because of that. GY is 42.2. Okay, good. JX is 28.8. You girls in the back need to stop talking and pay more attention. Okay, what else? That's all you got? Okay, so now we're trying to find the length of PH. Any bright ideas? None? Well, these are all right angles.
Just out of curiosity, those two are the
What's that? Yes, and why is that you going to say anything? What is this point called where the perpendicular bisectors all meet? Okay, and what's true about that is the centroid? You have your notes from when we did the center of balance, So what does that tell you that is true about that point? Yeah. What's that? What is what all congruent? I don't know about that. I don't think that's all the triangles are congruent. No. What's true of the orthocenter here, the perpendicular bisectors? Yes.
The lines from the vertices.
Into this point are equal. Is that what we get? Okay, say that one more time.
It says the centroid is the center of gravity that divides the median into two pieces divided by 0.
Okay, I don't like that. This is the orthocenter, right? What does it say true about the orthocenter?
It's a special property, and then it does inside, outside, or on.
Okay, so it's more work than I thought. All right, so here we go. Sorry about that. I thought there was some fun property of the orthocenter that we could use to make this really easy, but unfortunately there's not, okay? But what we're going to do is we're going to look, and since these are altitudes, they make a right triangle. So I'm going to use this right triangle right here to figure out what this side is, okay? You guys can all do that, right? So I'm going to say px squared plus 28.8 squared equals 46 squared. Anybody got that going for me?
Can you just put the 46 repeated?
I don't know that we can, but we're about to find out. Okay, that may be true, but I don't want to assume that it is. So somebody tell me what 46 squared minus 28.8 squared is, and then take the square root. Well, I just want to solve this little equation right here real quick. Does it come out to be 36? Okay. Okay, so px is 36. Okay. So then to find pg, which somebody has made the conjecture that it's also going to be 46, but we'll find that out. Since this is a right angle, 36 squared plus 28.8 squared is going to equal pg squared. So you guys can do that, I'm pretty sure, while I write this out for our viewers at home. And across this great land of ours. So 36 squared plus 28 point, what is it? It does come out to be 46? Okay, so does that mean that this is just going to be 46 too? I don't know either. Let's find out. So that's 46, because we have a little isosceles triangle going there. Is that what you were working with? Okay, so this is 46, this is 42.2, so now we can use that to figure out what this is, right? So py squared plus 42.2 squared there we go, equals 46 squared, right? So what do you get from that? 18.3. Okay. And then finally now we can go 18.3 squared plus 42.2 squared equals ph squared. Seems like it. Oh, you're going to go jump back there. It's 46, so it does come out to be the same. Okay. All right, so what did we do that? Take that 10-minute problem, and all we had to do is just say, since these are all altitudes, they meet in the middle, they're the same distance from all the vertices. That's the problem. Okay, so 2-second problem. All right. Good job. Way to overthink it. All right, well, let's keep going here. Number 7. So we know, okay, so this one, now we've got this triangle here, and this is the thing that Dakota was helping us with on the last problem. It turns out we did not need. Since these things are all the bisectors of the side, what are all these lines called? Not altitudes, because they would have to make a right angle there, and they don't necessarily do that. What? They're not perpendicular, there's no right angle here. Medians, yeah, these are the medians of the triangle. The medians go from the midpoint of the side, which that's the midpoint because these two sides are the same, to the opposite vertex, okay? And what Dakota told us on the last problem was, what is true about this segment right here compared to this segment right here? Right, this little guy right here is half of that. This little guy right here is half of that. And this little guy right here is half of that. So if dB is 24.6, so this entire thing right here is 24.6, the first thing we need to figure out is what is dZ. So if dB, the whole thing is 24.6. No, because it's the whole thing that's 24.6. And so this is 1/3 of it, and this is 2/3 of it. Because this is half of that. Okay? So what you have to do is take that and divide it by 3. So 24.6 divided by 3 is 8.2. Right, and then you double that, and that means that dZ is 16.4. So that little piece is 8.2, and then since the other one is twice as big as that, it must be 16.4. Okay, then it says EZ is 11.6. So now you can do it the easy way. What is VC? What? 5.8 because it's half of the 11.6, right? Because this little guy is half of that one, so this is 5.8. And then the last one on the diagram is EC, and obviously to get that, you're going to just add those together, and that would give you what? 17.4. Okay? So, number 11 says UA and BA are angle bisectors. So what do you know right away from that? This is 20, that means this is 20. Okay, so can you figure out this one up here? I don't know if you have to, but just for funny, can you? Yeah, because these make 40, plus that makes 106, right? How much is left over for this whole angle right here? 74, so that means they are each. Okay, I don't know if that's important or not. It says find the distance from A to UV. So we are trying to find the distance straight across as a right angle from A over here to UV. Okay? Anybody have any fun ideas? Bless you. This one that I just drew? Oh, this one? No, I don't think so. What would be a right triangle would be this right here. Okay, so doesn't that look hauntingly familiar? Isn't that the same thing as we stumbled on in the very first one? So can you tell me like what the answer is right now? So 18. Aren't these two triangles going to be congruent right here? Right? Because these two angles are the same. These sides are the same. Suppose we need another side or an angle in there. Oh, we've got the right angle then in there also. So we've got angle, angle, side. So those two triangles are congruent. So that means this is the same as that. And so that means the distance from A to UV is 8.
You are awesome.
Okay? Okay, so that is a little bit on the, you know, those things with the medians and the perpendicular bisectors and the angle bisectors and things like that. So you might actually, at some point, before you take this test, spend a little time looking over that sheet and trying to remember those things, because those are handy little things to know. Okay? Or you could go Alexis and you could look at it and go, that's 46. That looks like it's 46. Must be 46.
Yeah.
And then she's right.
It's pretty good.
Yeah. All right, so then the next section in here is on the triangle thingies that we did. So the first one says, which theorem or postulate can be used to prove that triangle ABC is congruent to triangle DBC? What do you like? You like what? A, SSS, yes, because they told you that this side is the same as this side, that side is the same as that side, so there's two of our S's. Where did you get the third S from?
The same side.
Right, the thing in the middle is congruent to itself, so that means it must be the side postulate or conjecture right there. Remember when we did these? You guys loved these so much. Such good times. Okay, how about this one? Which one do we know, or how do we know that those two triangles are congruent? What? Side angle side, because they gave us the two sides. And then why do I know this angle is congruent to that? Vertical angles, so those two triangles are congruent by side, angle, side, which is answer choice B. Okay? Okay, number 3. We've got the triangle on top of each other situation. So what do we got going here? It says this angle is congruent to that angle. We're also told that JL bisects KLM. So that means that this angle is the same as that one. So what do we got there?
Angle, angle, side.
Angle, angle, side. Yes, because this side is congruent to itself. And so I've got angle, angle, side here, and I've got angle, angle, side here. So I have angle, angle, side. Okay? Good deal. So these aren't so bad, right? So we get to number 4.
I don't get it.
Which is one that is not in our textbook. It is the HL. I don't, did we do that one?
No, I thought that on the page though.
Yeah, on the list that they gave you at the beginning.
Yeah.
Yeah, that's one that is not in our book. The HL conjecture is that if you know the hypotenuse is the same and you know that one of the legs is the same, then you know the two triangles are the same. And it's just a shortened way of saying you could do this. The reason why you know that this works is because if this is the right triangle, this squared plus this squared equals this squared, right? And this squared plus this squared equals this squared also. So what's going to be true about these two sides? They're going to be the same. So if you have two sides of a right triangle the same, then the whole thing must work out as long as one of them is a hypotenuse. Okay? So the answer for number 4 is hypotenuse leg, which is B. Okay? Okay, and then a little bit of practice with proofs. There will be some proofs on the test, so that's good, because everyone loves them so much. And they're so easy to do. Okay, so for this one right here, it says QP bisects RQS. So that means these two angles are the same, right? And then it says QR is the same as QS, and that's marked on the diagram also. So those two are the same. So this is Q, R, P, and S. All right, they've done most of it for us. You remember that always your proofs start out with the given information. So they wrote down QR is congruent to QS. We know that because it's given. We know that QP bisects angle RQS because that is given. And then what statement would go with the definition of bisector? Okay, good. Number 3, the statement is angle RQP is what? PQS. Okay? So the definition of an angle bisector is it cuts an angle into two equal pieces. So if this is an angle bisector, that means that this angle here, as I have labeled, has to be congruent to that angle right there. Okay? What's that? Yeah, that's the triangle. So that's the final deal there. Okay, number 4, then we also know the statement is that QB is congruent to QP. How do we know that? Same segment. Does anybody remember the fancy word for that?
Seems like this.
The It's also called the reflexive property, right? Because when you look at your reflection, you're seeing the same thing. So it's equal, okay? All right, and then the last thing they say is the two triangles are congruent. Oh, and I'm going to throw this in here. And how do we know that's true? Side, angle, side. You knew that. Okay, so that was our old friend, the two-column proof, where you have your statements on one side and your reasons on the other. Another way that we proved things this year was with the flow chart, which is what number 6 is. So let me draw this up there. All right, so this one says JL bisects angle KLM, and angle K is congruent to angle M. And we're going to once again show that the two triangles that are formed are congruent. So just like before, it starts with the given. It says JL bisects angle KLM, given. Then it says KLJ is congruent to MLJ. So KLJ is this guy right here, and that's congruent to MLJ. And there's a little line there. We got to fill in the blank. What? Huh? Definition of bisector. Yo. Then off to the side they have the other given, which is that angle K is congruent to angle M. And then we have to fill in the statement. They say the reason that we know it's true is the reflexive property. What could that possibly be? JL is congruent to itself. That'll work. Same thing. Okay, and therefore we know what to be true by angle, angle, side. And then this is a great, this relates just to what Dawson said. You can write JL or you can write LJ. Same thing with the triangles. I can write this top triangle any way I want. But once I write the top triangle out, the bottom triangle has to match it. So how do you want to write the letters for the top triangle? J, K, L. Okay, and so J goes with J, so I'm going to start with J over here. K goes with M, and then L goes with itself there. So you have to match them up. What? Oh, okay, so instead of, so that's a good clue, all right? Okay, so that's not so bad, right? Okay, will you make sure your name's on those and pass them full?